Hello, brilliant scholars, my little academic achievers. We are watching Comp Academy. Get it? Compion's my last name, and this is Academy because I'm not at school. And it's all about parabolas. Parabolas are these U-shaped figures, so we're no longer talking about lines or exponential equations. So remember our knowledge on lines, right? They are straight lines. They can go that way with a positive slope, that way with a negative slope. Exponential we talked about before, that they were going higher and higher. They had this curve to them, or they're decreasing, looking like that. Okay, so it's not really a straight line anymore. It is a curved section, okay, but this lovely thing down here goes straight for a long time and then it starts shooting up for even longer time, or vice versa. It starts off really high and then it goes super low to zero for quite a while. Now with the new type of functions, we're talking about parabolas. So parabolas are these U-type figures, U-shaped curves that have a specific form. So the form that was so nice is that you're going to see this parent function is what I call it. It's the most basic curve, and we call that y equals x squared. So this graph right here that you see, my little pen is circling around it, is y equals x squared. It is considered a quadratic meaning that the degree is 2. We have learned about that in the past. And then we have lots of vocabulary words that goes along with it. Axis of symmetry is the first one, axis of symmetry. And what does the axis of symmetry do? Well, it goes through the middle of the graph. So everywhere that I draw this axis of symmetry going split dab in the middle of the graph, I can make this curve, or this parabola, every point on the left-hand side. If I fold it across that blue line, it will match up to every point on the right-hand side. So imagine there's that blue line that goes down the middle. That's what we call the axis of symmetry. And the parabola, if you fold it in half along there, like a hot dog, right? Fold it in half, the two sides will match up. Okay? So fold or the line that divides the parabola into two matching halves. One half is on the left and the other half is on the right. Axis of symmetry. So every single parabola has an axis of symmetry. And it does go through the vertex in number 4. We'll get down to that in a second. I like changing colors quite often. So now a parabola. A parabola is that U-shaped curve. It's not a line anymore. It is a curve. Okay, U-shaped curve. And let me see if I have a better definition. All right, so it's a U-shaped curve that is a quadratic function. Whoops, I spelled it wrong. Quadratic function. Okay, so it's a U-shaped curve. It's a thing like this. Now, it doesn't always have to point up. It can point down. It can point all over the place. Okay, so the definition of a parabola is it's a U-shaped curve that is a quadratic function. Okay, the next one says quadratic function. Hey, what is a quadratic function? Since we used that vocabulary word in the previous definition, it is a function that can be written in the form y equals ax squared plus bx plus c, where a cannot equal 0, because if you cancel out the quadratic term, you'll go back to a linear function. Okay, so this is considered standard form. There's many different forms. Standard form. And let me highlight what I'm talking about. This equation here is considered standard form. Okay, so those two go together quite nicely. Standard form of a quadratic function is y equals, it has to have an equation, an equal sign, ax squared plus bx plus c. And then there's this other more helpful form we're going to use a lot today, and that's vertex form. Now, I know I haven't really told you what the vertex was yet, but let's still write out the equation just so you know it. Y equals, okay, the a still is going to be there, and then we have this x minus h squared plus k. Okay, so that's if it's in vertex form. You can easily find what the vertex is, and we'll tell you in a second. Okay, so an example of this first one, the standard form. Let me make some more shading for you. So vertex form here is going to be this equation down below. Okay, picture or example. So there's one example in standard form that would look like y equals 2x squared plus 3x plus 4. Okay, so that's a standard form equation. And then for vertex form, you can say y equals 2 can stay on the outside, and then it's x minus 3 squared plus 10. Okay, that's another example in vertex form. I want you now to give me an example, please. Okay, perfect. So now the next part, quadratic parent function. So this is just a really simple parent function that I was talking about up top. And that parent function could look anything. It's usually going to be the most generic points that you'll use for this parent function on a quadratic equation is going to be like an x comma y table, and then you can use -1, 0, and 1. And if I'm plugging it into this y equals x squared, I know the y is going to be equal to x squared. So if I plug in a -1 and I square it, I'm going to get a +1. If I plug in a 0 and square it, I get a 0. And if I plug in a 1 squared, I get 1. So once you plot all those lovely points, you're going to get this parabola. Let me change colors. That looks like that. Okay, so it's a lot like this one up here, right? But you have 0, 0, 1, negative, or -1, 1, and 1, 1. The last part, like I told you before, vertex. The vertex is the top or the bottommost point on the parabola. Okay, so the top or bottom, depending on which way the parabola is opening, most point on the parabola. Okay, we normally call it h comma k. Those are the variables that we use, because if you see in vertex form, here's your h and here's your k. Okay, so that's going to be the vertex ordered pair. And up here, you see how this point right about there, let me get a big old bolded, that lovely point at the very top, you see the arrow coming towards it, is going to be the vertex of this equation. So let me change it to blue, and we can say that ordered pair is, we're not going anywhere left or right, so we're going to stay at 0, and we are moving the parabola up 1. So 0, 1 is considered the vertex of this equation. Okay, vertex is the top or bottom. In this case, it's the topmost point, and we are going to get to more vocabulary in a second, calling it a minimum or a maximum, depending on where it is going to lie. Okay. So next is just more vocabulary words. Okay, so I'm going to insert some questions if I haven't already along the way, and I would like you guys to fill out the information and go on with the next problem. So once again, this is the definition of a parabola, a U-shaped graph that such as one at the right that's called a parabola. Well, it's not at the right, so I'm going to draw a nice parabola right below here. Sorry for my lines, they're not the straightest. And then let's make the first one look like that. Okay, so there's a parabola. And then I'm going to draw another one over here. Let's say we're going up that way. And there's a second parabola. There's that vertex. And there's that vertex. Okay, so a parabola can open upward or downward. So this is the upward parabola. Okay, it's upward because the bowl, think of this as a bowl, right, parabola, and it's holding all these Cheerios, okay, or whatever kind of cereal that you like. So it's upward, and if it is upward, the vertex is going to be considered a minimum. Since it's at the bottom of the bowl, that vertex is going to create a minimum. Oops, I think I spelled that wrong. Minimum. Okay, so this vertex that's facing upward is going to create a minimum. It's the lowest point on the graph. So a parabola that opens upward has a minimum or lowest point. So this blue parabola is facing upward, and it's going to have a minimum point. The parabola that opens downward has a maximum or highest point. So we go over to the pink graph and see how this one looks like an umbrella, right? That all the rain is going to be reflected downward, right? You're going to have a little person in here and you're so safe from the rain. So this is going to be a downward facing parabola, and its vertex is at the top of the graph. So that's going to be considered a maximum, the highest point on the graph. Maximum. Okay, so this vertex is the very highest, and then it goes down lower, right? We're climbing, climbing, climbing. We hit a maximum, and then we start falling, falling, falling. So a downward facing parabola will create a maximum at its vertex. Okay, so once again, a vertex of a parabola is its minimum or maximum point. All parabolas have a line or an axis of symmetry. We talked about that on the previous page. Remember, whatever that line is, that will split the graph exactly in half. So this is the axis of symmetry, and it will always be x equals some number, whatever that number is. Because it's a vertical line, it's crossing through the x-axis. This axis of symmetry is going to be x equals, let's say, -5 if we're over that far. Okay, but all these points on the left of -5 will be folded across and match up to all the points on the right of -5. And then over here, same thing. I can draw my axis of symmetry coming through the middle of the graph. So you can see that it is coming through the x coordinate of that axis or of that vertex point. Okay, so it's still going to be x equals some number, and that number is whatever the vertex coordinate, the x coordinate of that vertex. Remember the HK we talked about before? Okay, the x-axis of symmetry will always be that h that we're going to talk about more. Okay, so that's a lot of vocabulary words. Going on. So a little bit of practice problems. I'm going to do the first one, and then I want you guys to answer the next two. Identify the vertex of the graph, and then tell whether it's a minimum or a maximum. So this first problem, it looks like it's an upward facing parabola. So that means it's going to have a minimum value, and that minimum value occurs at its vertex. So I can say first off, the vertex is going to be, you start at the origin, and I'm going to count over 1, 2, 3. So my x coordinate's 3, and then I'm going to climb up 1 to get to that point there. So 3, 1 is my vertex. And because it's an upward facing parabola, okay, you don't have to write this upward part, but I do know that this is the bottom of the graph, a minimum value. Okay, so that's going to be a minimum. If you want, and it's good practice, I am going to say also find the axis of symmetry. It's where I could fold the graph in half and all the points on the left match up to all the points on the right. So if I get my highlighter out, it looks like my axis of symmetry in the middle of the graph will go right through the middle there. It is a vertical line, so that vertical line is going to be x equals. And what is the x coordinate it's passing through at? Oh, yeah, it's the same as that h coordinate right there. So I know that the axis of symmetry is going to be at x equals 3. Okay, so you guys try the next ones. Okay, pause the video if you need me to. I'm going to keep going. Okay, if you need me to slow down, you just pause the video and then do it first before you watch it, please. And let's say you got stuck, so then you can come and watch it as well. So for problem number 2, it says to find the vertex first. So I find the lowest point on this graph because it is an upward facing graph. And I start at the origin. It looks like I have to go 1 to the right. So my x coordinate is 1. And then I have to go down 1, 2, 3, 4, 6. And because I'm going down, I have to put that negative sign in front. So the vertex of this lovely parabola, number 2, is 1, negative 6. And then it is an upward facing graph again, so I know that we have the lowest point on the graph is at negative 6, so we have another minimum point. Okay, another minimum because it's an upward facing graph. Axis of symmetry, get my highlighter out. Axis of symmetry has to go through the middle of the graph. It cuts everything in half. Fold this portion and it equals this portion if you did fold it. And that axis of symmetry is going through the x-axis. It is way up here, but it's still going through the x-axis. And it's going through all those x points, and the x point is the same as the vertex there. So I say it's x equals 1. Number 3 is a little different. We can still find the vertex, but in this case it is the highest point on the graph, which looks like right about there. You start at the origin and we go to the left. 1, 2, 3. Because I'm going to the left 3, it has to be a negative 3. And then I'm going down 1. Below the x-axis is going to be a negative 1. So my vertex is negative 3, negative 1. And then because it is a downward facing parabola, it is going to create a maximum at the top. A maximum. And once again, get the highlighter out. The axis of symmetry is going through the middle of that vertex, right? The vertex is crossing the x-axis at negative 3. So I write my equation of a line as x equals negative 3. Good job. All right, so let's see if you can tell me without graphing, how are we going to be able to tell without graphing if we're going to have a minimum or a maximum? Well, let's do a little bit of play action going on here. On Desmos.com, I pull up my screen. Let's see if I can make it smaller so it all fits in here so nicely. There we go. That works. So I already graphed the parent function. If you can see the red, y equals x squared, and there's the original parents. Okay, parent function just means like the most basic graph that you can do. And then I'm going to type in y equals x to the power of 2. So that's another one. But now I'm going to put a 2 in front. So if you compare that graph to my original red graph, do you see how the blue one is inside? So think about that. What does the 2 do to graph? It looks like it stretches it a little bit. And then I'm going to go to the next one and say y equals 0.5x to the second. And that's the green one. You can always check to see what function is graphing, right, by the color that's off to the side. So we had the blue one was originally... Sorry, the red one is the parent function, red for tritons, right? The red is original, and then I multiplied the 2 in front, and I got the blue one, so it's inside of the red one. It stretched it out, and then I did a 0.5. 0.5 is smaller than 2, and that made it fatter. Okay, so that's something to think about. What if I put a negative 1 in front? So y equals negative 1x to the second. Ooh, now it created that purple graph. Okay. The purple graph is now underneath. It's a downward facing parabola where all these ones were positive. Well, let's see if that continues. Y equals negative 2x to the second. Is that still downward? Right? So if negative 1 was the original one, because I could put a 1 in front there and it doesn't change it at all. Okay. And then the negative 1 down here, okay, it just flipped it below the x-axis. Negative 2 is now inside of that purple graph. And let's do another one. Let's say y equals negative, oh, not t. Y equals negative 0.5 x to the second. And there's another graph there. They did it like a maroon color. Okay, so once again, if you look at all the different graphs, you have the first one, which is that red in the middle. That's the most basic parent function. And then the blue one gets stretched taller because the 2 is a higher number. The 0.5, positive 0.5, made the graph go on the outside of the red one. It's fatter. The purple graph now is below the x-axis, right? But it looks like it's symmetrical to the original red graph. Okay, so just looking at that. And then a negative 2 in front made it go down below. And then finally the negative 0.5 is the fattest thing, just like the green one up top. So can you see any conjecture? Can you come up with a guess how we are going to get the graph to be below the x-axis versus how we're going to get the graph to be above the x-axis? Good. So I'm going to say you answered it correctly by saying if the a term in front, okay, so the a term in front is a positive number, the graph is going to open up. If the a term is negative, the graph is going to open down. If you look back at the graph once again, all of these a terms, the numbers in front, are positive and all those graphs are opening up. Below, we have all of these a terms, the number in front of x squared, right? X squared is behind here, and all the a terms are negative. All three of those graphs are below the x-axis. They're opening downward. Okay, so that's my conjecture, and you could have written it however you wanted. So now if I say y equals 2x squared plus 5, the plus 5 does not do anything for telling if it's going to be a minimum or a maximum. The only thing you're looking for is the a term in front here. And what is that, a positive or a negative? Ooh, the a term is positive. So since a is equal to positive 2, I know this parabola is going to open up. Because it's going to open up, hey, guess what? We have a minimum value. Drawing pictures are very helpful. Okay, so now I'll do the next one for you, and then I'll let you do the last two on your own. I find the a term is in front of the x squared, and that is a negative 1. So since the a term is a negative 1, it's going to open downward, the parabola. And if it opens downward, you have a maximum at the top of the graph. So that is going to be a maximum. So now I want you to try number 3 and number 4. Remember to find the x squared term first, and then look at the number in front of it. Okay, so let me make a little, oh, what happened there? Okay, so here's my a term, and then down here, here's my a term. It's a little bit trickier because it's in the back, but I have faith in you. Stop the video if you need more time. And here is my explanation. Because the a term in number 3 is 1/2, I know it's a positive a, so that means it opens up. And then it's at the bottom, the vertex is at the bottom of the graph, so this is going to be a minimum. Okay. The a term here is in front of the x squared. Since the x squared is here, that whole thing is my a term. So that's a negative 3. Because it's negative, it opens down with a downward opening. You know that's going to create a maximum. The vertex will be at a maximum. Okay, so we talked about these different forms. Today we are going to be talking a lot about, ooh, that's an ugly little shading. Sorry about that. Let's try this a little bit better. This is going to be the most popular form today. Okay, so that's a vertex form. Standard form and parent function. We already talked about the parent function just to graph the basic one, and then we can use the transformations to graph everything else. Okay, so we're going to, oh, I already showed you, right? What does the a do to the parabola? If you want to look back on Desmos once again, I changed a whole bunch of a terms already. Okay, you can play around with another screen if you want also on Desmos to just find your own different problems, right? But remember, if the a was positive, it opened upward, the parabola opened up. If the a is negative, the parabola opens down. The parabola opens down. And then you can get even more specific. If the a is greater than 1, just like this 2, if I make it, let's say, a 4, see how it makes it even skinnier? And it changes it also. If I change that to a negative 5, it makes the parabola even skinnier, this orange one down here. So the bigger the number goes, the skinnier the parabola goes. Remember, 1/2 or 0.5 is the same as 1/2. So if I wanted to change it to like 1/4 maybe, look at how much fatter that graph is now, right? It's even more fat than the skinny one. And I can do the same thing down here. Change it to 1/6 maybe. It makes it even fatter. So the more the fraction is, right, between 0 and 1, the a term will make the parabola either skinnier or fatter. Okay, so now let's talk about what the h does to the parabola. I'm going to go back to decimals, and I'm going to delete well, let's see here. Let me just delete what I can so I don't have to erase them all. This was our parent function, so I'm going to keep that there, and that's the red one. And then for the next one, the h is inside of the parentheses, so I'm going to keep the a the same every time. But now I'm going to make it x minus 1, and then I still have to put a square, because that square makes it into a parabola. Okay, so can you see here? Maybe I need to zoom in a little bit. Can you see here that if the original vertex, the original parabola, was at 0, 0, now I put an x minus 1 inside the parenthesis, and it looks like the vertex now, I can highlight it, and it's at 1, 0. So what did we do? We shifted the parabola 1 to the right. Well, let me see if I can do it again. Y equals x minus 2 to the second. And let's click on that vertex. Oh, that one's at 2, 0. So I started at 0, 0. I moved it 1 to the right by putting in a minus 1. And I put another one to the left. What do you think? What do you think is going to happen if I change it to y equals x plus 1 to the second power? Oh, now it's a purple graph, and that purple graph has an ordered pair, a vertex, of negative 1, 0. Well, that's pretty cool, because now that I have x plus 1, it's moving to a negative 1 vertex. Interesting. One more. Y equals x plus 2. Ooh, somebody loves me. I'm getting text messages. I bet it's my husband. He's so handsome. So can you make your own guesses? What happens to the h, right? If you change the h to, let's say, the minus 1, minus 2, plus 1, plus 2, which way does it shift the graph? Is it shifting it up and down, or is it shifting it left and right? And how do you get it to move to the right versus how do you get to move the parabola to the left? Okay, so I want you to write that now. And then lastly, we're going to see what happens to the k. What does the k do to the graph, to the parabola? So let's go back to our Desmos, and let's clear out all these extra graphs except for the parent function. So now we're back to the original function, and I'm going to say y equals x to the second, and then plus 1. Ooh, interesting. So it moves the vertex, instead of 0, 0, right, it moves it up to 0, 1. So we're not changing the x anymore. It looks like we're changing the y. Well, 1 doesn't tell me much, so let's try another one. Plus 3. Oh, well, that looks like it, because look at, now my vertex is at 0, 3. Well, how do we get it shifted down? Y equals x squared minus 3. Ooh, that's right. Look at that. Now the vertex is at 0, negative 3. Should we try one more, just so you unbelievers can become believers? Let's try minus 5. Look at that. Even though I made it a negative 5, it's still, the vertex is at 0, negative 5. Okay, so I want you to write me, what does the k do to the graph? Okay, how do you move the graph up, down, left, and right? What does the k do to the graph? All right. Good summaries, guys. Good summaries. So here's the problem where we want to find the vertex, the axis of symmetry, minimum or a maximum, and then write your equation in vertex form. Well, I'll show you the first one, and then I want you guys to try the second one. This is pretty much putting all the vocabulary and all the knowledge you learned in the past 30 minutes into one big problem. You guys are getting so advanced in math skills. I am so, so proud. So you guys are going to watch me with this one. To find the vertex, that's going to be the bottommost point. Okay, bottommost point is the vertex. So if I start at the origin, it looks like I'm going over 1, 2 to the left, and then up 1. So my vertex is at negative 2, 1. Axis of symmetry is that lovely solid line that's going to be going through the middle of the parabola that folds it in half, because it's going through the x-axis, right, at negative 2. I'm going to say it over here, x equals -2 is my axis of symmetry. It has to cross through the x-axis, and it crosses through at -2. Minimum or maximum? Well, because the parabola is facing upward also tells me that A must be positive, right, to get it to face upward. This is going to create a minimum value. So I'm going to put a circle or a square around the minimum value. And then write the equation in vertex form. We did them separately so far. We said, what does the A do to the graph? It makes it fat or skinny, and then up or down, faces up or down. And then it's x minus h. The h moves it left or right. And then plus k. The k moves it up or down. So knowing that the vertex is at -2, 1. Remember from before I said this is your h and this is your k, the vertex. So I can put in a -2 to that h, and I can put in a 1 to the k. The a is a little bit harder, but if you see that the first point is here and then you go up 1 and to the right 1, that is like a slope of 1 also, so that means your a is 1. So to write this whole equation, it is a positive 1. You don't have to write that. I'm just showing you it's opening upward, so I need my a to be a positive number. And then x minus, well, it's not a minus because we're shifting the vertex to the left. Remember, to shift it to the left, we need a +1. To make it into a parabola, you do need to remember that square up there. And then plus, the 1 moves the whole entire vertex up 1. So the k is a 1. And there is my first vertex form. I just substituted the h and the k using my transformation knowledge, and then I get my full my full equation. Okay, so I want you guys to fill in the next part. Stop the video if you need some more time before I go through it. The vertex looks like, if I start here at the origin, 1, 2, 3. I go 3 to the right, so it's a +3. And then I'm going to go up 1, 2. So my vertex is at 3, 2. And that's my h and that's my k for later on. Axis of symmetry, love drawing that vertical line going through the middle of the graph. And it's crossing through the x-axis at 3. So I can say x equals +3. And look at how it's the same as the x-coordinate of the vertex. Okay, same thing up here. The x-coordinate, or the axis of symmetry, was x equals -2, and it's the same as the vertex x-coordinate. This one, because the parabola is opening downwards, if you have a parabola that's opening down, the a term has to be negative. Okay, so just remember that. And because it is a opening downward, it is going to have a maximum for a value. And then writing the equation in vertex form, we have y equals, makes it into an equation. The a term, right, has to be negative this time because it's opening down. And then same thing here. If I go down 1, and over 1, that slope, right, is a 1. So I know the a term is a 1. And then we can say x, I moved it to the left. I moved the original function to the right 3 units. So it has to be x minus 3 squared. And then plus, I move the vertex up 2 because the k is 2. I put it right there. Please remember that squared. That's what makes it into a parabola, a U-shaped figure. If you forget the square, it's going to be a line. We don't want that. Great job today, scholars. We are finished. Give yourselves applause.